This video is going to talk about comparing fractions, sometimes by using equivalent fractions. Remember that when two fractions have the same denominator, or the bottom number, the fraction with the greater number is greater. Bigger numbers are bigger in the numerator. So when we look at this letter A, we see that we are asked to compare between 1/9 and 2/9. Well, 2 is bigger than 1, so our answer is going to be 2/9. The denominator is the same. When we look at letter B, 1/12 or 2/12, 2/12 is bigger than 1/12. 5/9 is bigger than 2/9. 43/87 is bigger than 35/87. Bonus question. So, they want us to fill out the numerators here to complete the list of equivalent fractions. So I'll do letter A and then I'll let you go ahead and do letter B. On letter A, you can see that to go from 4 to 8, you would multiply by 2. 4 times 2 is 8. So then you'd also multiply the numerator by 2. 3 times 2 is 6. 3/4 is the same as 6/8. Let's go on to the next one. 4 times 3 is 12. 3 times 3 is 9. 4 times 4 is 16. 3 times 4 is 12. 4 times 5 is 20. 3 times 5 is 15. 4 times 6 is 24. 3 times 6 is 18. 4 times 7 is 28. 3 times 7 is 21. 4 times 8 is 32. 3 times 8 is 24. You go ahead and try the next one, and when you come back, we'll talk about it. Welcome back. 7 times 2, 7 times 3, 7 times 4. We can see that this pattern continues. It's just going up according to the multiplication tables. So let's do the same thing with 5. 10, 15, 20, 25, 30, 35, 40. Now, the cool thing is every fraction in letter A is equivalent. They all mean the same thing. They can be simplified to the same fraction, 3/4. When we look at letter B, all of these fractions also equal the same thing. They all reduce down to 5/7. So, why do you think we use the term common denominator? Could it be because it's fractions that have a denominator in common? Wow. So remember that the word common was used for common multiples and common factors. They want us to create a list of equivalent fractions to find a common denominator and then figure out which one's bigger. We're going to do this slightly differently. We want to know, what do 5 and 3 have in common? Well, if I take my 5's tables and I go 5, 10, 15, ooh, I know that 3 can go into 15. Let's try our 3's. 3, 6, 9, 12, 15. So we found that there are 15's in common, which means that we can change both of these to the denominator of 15. For example, 2/5, to get that to a denominator of 15, 5 times 3 is 15. 2 times 3 is 6. 1/3, to get that to a denominator of 15, 3 times 5 is 15. 1 times 5 is 5. So you're at 6/15 and 5/15. We know that 6/15 is bigger, so 2/5 is the bigger fraction instead of 1/3. Let's look at 5/6 and 7/9. So going along our multiplication tables for 6, we know 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36. Let's see what we got there. We know that 9 times 1 is 9, 9 times 2 is 18. Wow, would you look at that? These both have the number 18 in common. So let's change 5/6 into something over 18? Well, 6 times 3 is 18. 5 times 3 is 15. Now, for 7 over 9, we know that 9 times 2 is 18. So 7 times 2 is 14. And by looking at 15 eighteenths and 14 eighteenths, we can see that 5 sixths is bigger than 7 ninths. Over here, we have 5 eighths and 3 fourths. I don't even need my multiplication tables for this. I know that 4 times 2 is 8. Great. So I'm going to change 3 fourths. I'm going to multiply 4 times 2 and get 8. 3 times 2 and get 6. Now I'm comparing 5 eighths and 6 eighths. 6 eighths is bigger. So, 3 fourths is bigger than 5 eighths. Over at letter D, we have 7 twelfths and 8 fifteenths. I'm going to go ahead and do the 12 because I know that it has to be something that's divisible by 15. And I know 15s can go 15, 30, 45, 60, 75. 12s are 12, 24, 36, 48, 60. Hey, look, they both have the number 60. So I'm going to take 7 over 12 and put that with a denominator of 60. 12 times 1, 2, 3, 4, 5. 12 times 5 is 60. 7 times 5 is 35. 8 over 15, to get that to a denominator of 60, 15 times 1, 2, 3, 4 is 60. So 8 times 4 is 32. 35 over 60 is bigger than 32 over 60. So 7 twelfths is the bigger fraction. Note that I keep mentioning the original fraction. You want to go off of the fraction that the original problem gave you. So they want us to find equivalent fractions with the same denominators without listing things. So one way to do that is just to multiply the two denominators together. So I would take 5 sevenths. Nope, that didn't look right. I would take 5 sevenths and 3 fourths. And I have this thing called the octagon, which won't 100% fit here, but that's okay. We're going to take out the 5 sevenths. And we're going to take 5 sevenths and multiply it by the other denominator. See that 4 over there? So we're going to multiply 5 sevenths by 4 over 4. 5 times 4 is 20. 7 times 4 is 28. Then I'm going to do the same thing on the other side. Take out 3 fourths and multiply it times the other denominator, times that 7. 3 times 7 is 21. 4 times 7 is 28. 21 28ths is bigger than 20 28ths. So 3 fourths is bigger than 5 sevenths. Let's go ahead and do the same thing with these problems. So I can, actually, if you look at this problem, I don't need to do that octagon. I can see that 3 fourths, I can change 3 fourths into something over 8. 4 times 2 is 8. That's already the other denominator. So 3 times 2 is 6. 6 eighths, 7 eighths. 7 eighths is bigger. I can change 1/3 to something over 12, and I have less work to do. 3 times 4 is 12. So 1 times 4 is 4. 5 twelfths is bigger than 4 twelfths. 1/2 to 3/10, I can make 1/2 something over 10. 2 times 5 is 10. 1 times 5 is 5. 5/10 is bigger than 3/10. Now, over here, both of these denominators need to change. This is where we're going to use that octagon that we were talking about before. So we have 3 fifths and 5/8. We're going to take both of these fractions out. Nope. Nope. Double no. Oh my. Kids, the world is just shifting on me. Go back. No? Don't care to? That's fine. All right, so we have 3/5 and 5/8, and we took both of those out. What we're going to do is we're going to multiply each fraction by the other denominator. So 3/5 is going to be multiplied times 8 over 8. 5/8 is going to be multiplied by 5 over 5 because that's the other denominator. 3 times 8 is 24. 5 times 8 is 40. 5 times 5 is 25. 5 times 8 is 40. 25 over 40 is bigger than 24 over 40. 5/8 is bigger. Let's go ahead and do letter E. We have 2/3 and 3/4. Take out the 2/3, multiply it by the other denominator, 4. 2 times 4 is 8. 3 times 4 is 12. That makes 8/12. Take out 3/4, multiply it by the other denominator, and you have 3 times 3 is 9. 4 times 3 is 12. 9/12 is bigger than 8/12. 3/4 is bigger. Let's go ahead and look at the last one. 8/11 and 2/3. Take out the 8/11. Take out the 2/3. Multiply 8/11 by 3 over 3. Multiply 2/3 times 11 over 11. 8 times 3 is 24. 11 times 3 is 33. 11 times 2 is 22. 11 times 3 is 33. 24/33 is bigger than 22/33. So 8/11 is bigger. So when we come over here, we see the lowest common denominator of the fractions. Now we could go through here and we could continue to change these fractions time and time and time again. But let's go back here and look for a pattern. Did you notice that both times we were multiplying both numbers by the other denominator? So you would multiply 5 and 8 and 3 and 8. You would multiply 8 and 5 and 5 and 5. And if you were to multiply 8 times 3, you'd get 24. If you were to multiply 5 by 5, you get 25. When we compare over here, we see that we'd multiply 3 and 4, and we'd get 12, which we got in the denominator. 3 times 3 would get us 9. 4 times 2 would get us 8. See how we're getting the same number, but with less work? When we come down here, we could multiply and do all of this work, or we could say 11 times 3, we know that's 33, we did it both times. We don't care about the bottom number, we care about the top number. So what we're going to do is we're going to multiply 11 times 2 and get 22. We're going to multiply 3 times 8 and get 24. The only thing you really have to do when you're comparing two fractions is cross multiply and make sure that you write the answer up above. 8 times 3, 5 times 5. 4 times 2, 3 times 3. 3 times 8, 11 times 2. Let's go ahead and look at this over here. 6 times 9 is 54. 10 times 5 is 50. If we were to multiply the denominators together to get a common denominator, we'd get 60. But they both have the same denominator. So what's bigger, 50 over 60 or 54 over 60? 54 over 60. So 9/10 is bigger. Let's look over here. 4 times 5 is 20. 6 times 3 is 18. We don't even need a common denominator because we know that our method would get that. What's bigger, 18 or 20? 20. So 5/6 is bigger. Last one, 6 times 7, 42. 9 times 5, 45. 45 is bigger, so 5/6 is bigger. That's all you really got to do. Or you could go through and you could look at this work and you could do it that way. There's nothing wrong with it. You do what works best for you. Now, when we're comparing with a mixed number, if the whole number is the same, you can ignore the whole number and just compare the fractions. So what's bigger, 3/4 or 2/3? Well, let's say you're not great at drawing fractions and separating them. This would be 3/4 and this would be 2/3, hoping I did it right. Instead, let's do 4 times 2 is 8. 3 times 3 is 9. 9 is bigger than 8. 3/4 is bigger than 2/3. So that means that, I don't even know what that is. That means that 2 3/4 is bigger than 2 2/3. And if you want to see the work, please go back. I don't know why it erased. So, same thing over here. Let's go ahead and compare these fractions, these mixed numbers. 3 1/2 or 5 1/3? 3 and something or 5 and something? Which one's bigger? 5 and something is bigger than 3 and something. 4 2/3 or 4 3/5? Well, since the whole number is the same, let's compare the fractions. 3 times 3 is 9. 5 times 2 is 10. 10 is bigger, so 4 2/3 is bigger. Letter C, 7 5/8, 7 3/4. The whole number is the same, so let's look at the fractions. 8 times 3 is 24. 8 times 3 is 21. No, 8 times 3 is 24. Everything is fine. Nothing's wrong. 5 times 4 is 20. 24 is bigger than 20, so 7 3/4 is bigger. Remember that you can compare negative fractions by comparing the positive opposites. So we know that 3/4 is bigger than 1/4. So remember that when we add the opposite signs, we also use the opposite symbol, because the smaller the fraction, the more you get to keep when it's negative. So if we look at 3/4 to 5/8, 4 times 5 is 20. 8 times 3 is 24, which means that 24 is going to be the bigger number. So if we look at negative 3/4 and negative 5/8, it's going to flip. And now it's going to be negative 5/8 is greater than negative 3/4, because negative 5/8 is you losing less. When we look at 5, 6, and 7/8, 6 times 7, 42. 8 times 5, 40. 42 is bigger than 40. So when we take 5, 6, and 7/8, 7/8 is bigger. Negative 5, 6, and negative 7/8, negative 5/6 is bigger. Look at the thermometers as they're showing the temperature between 2 whole number degrees. Sometimes it can show on one side and on the other. There we go. So when we take a look at which temperature is warmer, 3.5 degrees or 3 5/8 degrees, I'm going to go ahead and let you work this out, and when you come back, we'll talk about it. Welcome back. So I know that 1/2 is the same as 4/8. So 3 4/8 or 3 5/8. 3 5/8 is warmer. That's a little bit higher. -3.5 or -3 5/8. Well, now that we're going into negatives, I still want to be higher up on there. And -3.5 is a little bit higher up because remember how the opposites work. Then I have -5/3 or -7/4. They're improper, but it doesn't matter. 3 times 7 is 21. 4 times 5 is 20. Now, these are both negative fractions. And because they're both negative fractions, I want to take the smaller one because that's less of a negative temperature. So -5/3 is just a little bit warmer. Now, they've got this bonus here where they have a mixed number and an improper fraction. You can choose to change the mixed number into an improper fraction. You can do 3 times 4 is 12, plus 1 is 13/4. Or you can choose to make the improper fraction into a mixed number. 8 goes into 20 2 times, because 8 times 2 is 16 with 4 left over. So that's 2.5 or 2 4/8. Personally, I would rather work, when we look at this, it's easier for me to see looking at the mixed number here, because -4 or -2.5, I'd rather be in -2.5 weather than I would -4 1/3. Thank you so much for sticking with this video. I hope that you have a fantastic rest of the day.